Today, Lola and I will talk about the cellular and molecular aspects of the Ebola virus. The first question is, how does the pathogen affect body cells, which cells, and why? Ebola's RNA holds the information for creating new virus particles. To reproduce, Ebola must enter a living cell. The virus attaches to a nutrient traveling through one of the entryways in the cell membrane used to take in food. The Ebola virus will enter the cell by macropinocytosis. Once the Ebola virus has entered the cell, the virus uses the cell's organelles to reproduce. The cell can no longer carry out the processes it needs to survive because the virus has taken over its machinery, resulting in either the death of the cell or the inability for it to function properly. After the new virus has assembled itself, it then uses the cell's membrane to make a safe capsule for the virus to travel to nearby cells. The Ebola virus targets specific body cells: liver cells, cells that line the blood vessels called endothelial cells, and cells in the immune system. The virus targets liver cells so that the body is unable to get rid of toxins in the bloodstream. Ebola also targets the immune system cells because these cells travel throughout the body, and thus the virus will be able to spread quickly and increase its area of infection. A protein made by the virus called glycoprotein will negatively affect cell adhesion. Body cells need cell adhesion to be able to stick to each other and to the extracellular matrix, which is necessary for healthy body tissue. In blood vessel cells, this can cause hemorrhaging and internal bleeding. The ultimate result of the Ebola virus can be organ failure and shock caused by internal bleeding that will eventually lead to death.
Okay, so our second question that has to do with molecular aspects of disease is what are some molecules that can be used as therapeutic medicines to control the virus, and how do they help? To start off, Ebola is a single-stranded negative sense RNA molecule, and while many drug companies are developing vaccines, there is technically no cure for Ebola. Although none of these vaccines are ready for full-scale production or even approved for human treatment, they still have been in the works. So these vaccines use non-virulent portions of the virus injected into the body to teach the immune system to recognize the virus and defend your body against what's happening and what's multiplying inside of your body. And although the vaccines would usually take months or years for approval, emergency protocols have sometimes approved them to be used on Ebola patients. And there have been proof that it has worked. However, the CDC states that injecting electrolytes and fluids into the veins also allows for a stable balance of healthy bodily fluids, as well as providing oxygen for patients that need to maintain a regular oxygen status. And if patients were to show symptoms of vomiting, diarrhea, stomach issues, etc., blood pressure medication is used to address and help that. Regerin and MAB114, I don't know if I'm saying that correctly, are two antiviral drugs used to help Ebola patients. And these drugs kind of just go further into helping the virus not spread and also not copy itself, because this virus, if it's not addressed, it will copy itself. Another source of treatment is injecting these small interfering RNAs, siRNAs. These small pieces of RNA are designed to match a substrate to the virus's RNA. siRNA encounters the corresponding viral piece of RNA, it sticks to it, so it kind of acts as a mock RNA to it. So once it's stuck to the siRNA, the viral RNA cannot be used to create new Ebola particles. This also goes into furthermore the whole process of it copying itself. That's how dangerous it is. Thus slowing down the replication of the virus. And the FDA has recently approved siRNA therapy for use in the current outbreak. So that is something that has been happening that has helped a lot. And another treatment method is using antibodies, which is kind of something we're seeing similarly now with the coronavirus. That these antibodies are these Y-shaped proteins, if you didn't know, that are designed to recognize and neutralize things that your body's not used to, foreign objects in quotes, such as bacteria or viruses. So currently the most well-developed drug is called ZMapp, and that is a cocktail of 3 antibodies. The antibodies have a lock on the tip of the Y that recognizes this specific key or substrate or the substrate that it'll go into. In this case, a specific portion of the Ebola virus glycogen described in the previous thing I was saying. Once bound, the antibodies neutralize the glycogen, which will keep the virus out of the cell,